Hey guys, welcome back to AlgoYogi. We are doing array and hashing series. Our next problem in the list is maximum ascending subarray. So let's go to LeetCode. Given an array of positive integers, nums, return the maximum possible sum of an strictly increasing subarray in nums. We just solved a problem which was longest strictly increasing or strictly decreasing subarray length. This time it's asking for sum. So maximum possible sum of an strictly increasing subarray. A subarray is defined as the contiguous sequence of numbers in an array. So contiguous sequence is different. Contiguous sequence is different. So sequence and contiguous sequence are different thing. Contiguous means they have to be all connected together. All right. So we'll take the first example. Let's go over this, how we are going to do. Just like the maximum, either longest increasing or longest decreasing strictly array problem, subarray problem, we'll do the same thing here. So what we are trying to find here is this strictly increasing subarray. So let's see what are the strictly increasing subarrays here. So let's see. So I see that 10, 20, 30, then 5 is not part of that. So then this is one subarray. This is one subarray. Then 5, 10, 50. This is another subarray. So what is this sum? Sum sigma of all of these. 10, 30, 30, 30, 60. Sigma is 60 here. And then here 10, 50 is 60, and then 5, 65. So this is my answer. This will be my this is my answer, right? So, but how are we going to do it? How are we going to do it? So we'll basically initially have a longest, increasing sum of subarray as we will initialize it with the first number. So we'll use a for loop and we'll go from left to right, and I will basically start with the first 0th index, and I'll say the longest increasing or strictly increasing subarray sum. So sum. Initially what I'll say is that this is going to be nums. I'll say nums 0th position. And we will handle the case if the length of the nums is 0, then we will return 0. But then I will also have current longest sum equals to 0. Then what I'll do is I will start my for loop. So what I'm trying to do is initially I'll say that this 10 is the longest or current longest sum that you are seeing, but then I'm moving forward, then I will increment this, both of them, to basically 30, because this 20 is greater than 10. Then I'll include this 30 as well. I will keep updating my current longest sum, and then at the same time at the end of the for loop I will also update this LSI sum, because this is the value at the end of the day that I will be returning. So for I in range, I will start with 1, go up to length nums, right? And then if my nums at I is greater than, strictly greater than, not just greater than, only greater than, not or equals to, so nums I minus 1, that means I can add that value to my current longest sum plus equals to that value. We will update this, right? I. And else what I'll do is I will reset this. I will reset this to basically what we had in the beginning. I will reset in the right, and then another thing that I'm gonna do is update these values. So what I'll do is, so let me I will update my LSI sum out of this else. So LSI sum will be maximum of LSI sum or this current longest sum, right? Because I'm trying to increase this. So that's it, and then I will return LSI sum. That's it, guys. That's the entire solution, and it will be of time complexity of big of n. You're only iterating the entire array once, and you are not using any space, so space is constant. That is the best solution. Let's implement it. It's easy peasy. So as I said, we are going to have, you know, a variable called longest strictly increasing sum, and we are going to initially say, you know what, if the length of nums is equals to 0, then we will return 0. That's the best sum that we have. But otherwise, initially what we'll say is going to be the first value, and current longest sum is also going to be nums 0, right? That's the max sum that you have seen, strictly increasing from these strictly increasing values. So otherwise we'll say in range from 1 to len nums, and if nums at I is actually greater than nums I minus 1, you want to add this to your current longest sum. So current longest sum is basically plus equals nums value, nums at I value. Else you want to reset this to basically your current num value. So I think I resetted it properly. Did I? Okay, so I think I made a mistake. Just little quick update here. I don't want to make it 0. These two also I don't want them to be 0. I will actually have the first one this value, and the second one right here nums I. Okay, nums I, because I'm starting the next sum with nums I. So that was a mistake, not even typo. Okay, so longest current sum will be nums ith value, because I will start looking from my current position, right? Okay, otherwise I will update this LSI sum with maximum of current longest sum or LSI sum that previously I've seen, which might be greater. So, and finally I can just return LSI sum. All right, so let's zoom out and test our code. Test it. Awesome. Let's submit. Boom, 100%. All right, this is the best solution so far. All right, I'm sure you can make it less verbose. Time complexity, I solved it for the first time, so I will update it later. Space complexity, although I don't think there is any better solution than in terms of bringing down any time or space complexity. Space complexity is constant, so you can't bring constant any down, and time complexity also, because you have to visit all the element at least once, and that is big of n. Let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem. Bye-bye.